All right, well, good morning, everybody. Thanks to all of you for coming. I've got a lot to get into here, so I'm going to just jump right into it. Hold on, it's going to be a fast ride. 34 years ago to this very day, in fact, Linus Torvalds put out a little announcement saying that I'm doing a free operating system. It won't be big and professional like GNU. Well, since then, this happened. This is the size of the kernel over time. So I think that we can conclude that for perhaps the only time ever, Linus Torvalds was wrong, and Linux is big and professional. But I want to point something out about this upward going line that we see. It's quite unremitting. It's always upward, despite the fact that there were a lot of things happening in the world over these 34 years that you might think would have affected things. You know, we had the dot-com crash and came in 2000. We had the SCO lawsuit that came after that. In 2008 was a global financial crisis that roiled the world in many ways. More recently, we've been through the depths of the COVID pandemic. But if you look at these events, you see really no effect at all on the development of the Linux kernel. There's really nothing to be seen there at all. So the question that I want to get into here really is, how is it that we built a community that can be that robust and can develop that sustainably? And what sort of lessons have we learned along the way? And to follow this up, I'm going to kind of follow a theme from this famous quote from Mahatma Gandhi. That first they ignore you, then they laugh at you, then they fight you, and then you win. So we started by being ignored back in the early days of all this. If you look at the very first release of the Linux kernel, which came out shortly after that announcement, it was about 10,000 lines of code. It was missing a few minor and significant features like a graphical interface or the ability to talk to a network, multiprocessor support, or the ability to run on anything other than a basic x86 processor. This kernel was, in other words, a toy. It was a toy kernel at this point. It was something you could play with, you could try to make better. It was not something you tried to do anything serious with. It was easy to ignore. But what we saw here was the initial phase of what Clayton Christensen has called disruptive innovation. Right? Some new technology comes along and it's obviously far worse than anything that is already out there, and so you don't pay much attention to it. And then you wake up one morning and you find it has grown when you weren't looking and is now far better than anything that you have to offer. So there were a number of other factors at play that helped to keep Linux in the sort of ignored category at this point. The beginning of the Linux era was really the end of the Unix era, where it seemed like Unix systems, proprietary Unix in particular, was going to be the operating system of the future. Right? Unix had a good run, but the Unix vendors each made their own version and kind of made it buggy and awful in their own way. And really kind of tore that market to pieces. Meanwhile, Microsoft was on the rise. It was very common to hear in the early 1990s that everything was going to be Windows. All right, not just desktops, but servers, mobile systems, whatever. It was all going to be Windows. That was just kind of the accepted wisdom. And there was this perception that only big companies could do kernels. This was not something that some group of developers in their basement, as we were kind of characterized in those days, could possibly do. All of this kind of kept Linux off the radar for quite some time. It was really ignored in many circles until, like I said, about 1998. So what happened in 1998? The inflection point was truly when Netscape gave up on trying to be in the browser business and announced that they were going to release the source code for their browser to the world. This was almost kind of unheard of. Right? The term open source did not exist yet at this point. This was a new thing, and it brought a lot of attention to this whole idea that actually maybe you can release the source to your software, something that some of us had known about for quite a while, but a lot of the industry did not. And this led to a lot of, say, manager types going to the technical people and saying, I've heard something about this Linux thing. Do you know anything about it? And their technical people answered they already had it running all through their operations, because at the lower levels, people had understood it for a while and had been deploying it everywhere because it was free and easy to deploy and you could do that. So all of a sudden, Linux is in the spotlight as a result of all of this. And that brought to light the development process that Linux used. Now, Eric Raymond, for all of his faults, put his finger on something here. which is that the way that Linux was developed was a bit different than anything that came before it. Looking either at proprietary software or looking at the free software projects at the time. Look at the GNU project, the X Consortium, the BSDs. All these projects were run in a very centralized sort of way, with a small group of people who could really work with the software and make decisions, and who would every now and then deign to toss out a release that everybody else could use. Linux instead was open to everybody. Linux would take patches from anybody. There were no boundaries. Anybody could throw stuff out. A lot of people did. Not all of it got used. Not all of it was useful. But it was a very different sort of environment, a much more active, more participatory sort of thing, with much more instant gratification, because you would see your code, if you were lucky, in the next development release in the very near future. This allowed the community to grow in a way that other communities did not. In this time, the BSD systems were objectively far better operating systems than Linux was. They were far more mature, far more useful, but Linux quickly outstripped them. And much of it had to do with this process building a different kind of development community that brought a lot more people into it. So first lesson I want to draw here is your development process matters, right? The way that you set up your project, the way you accept contributions will have a lot to do how successful your project is going to be. A related aspect that played into this was licensing and the choice to use the GNU General Public License for Linux. Right? Copyleft licenses do have the effect of reducing forks. Right? They have a strong incentive for everybody to work on one common version of the code, and that happened here. Right? We have a Linux kernel. We don't have a whole bunch of different fragmented Linux kernels in a way that people had feared. Related to that is the copyright ownership policy, where everybody retains the ownership of their copyright. That makes it impossible, really, for any one person or any one company to pull the rug out from under you on this software. It makes it easy to contribute with confidence that your contributions will not be used against you in the future. So, obvious lessons, the licensing too really matters here. Finally, there was a big important sort of emphasis here was the kernel developers worked only on the kernel, right? If you look at how most other operating systems were managed, the developers worked on the whole system from the kernel all the way out to the user-facing utilities. Kernel developers really only worked on the kernel, and they left all the rest of it to other people. That allowed a lot of innovation to happen in user space stuff, and especially in distributions and the way that you build a functioning system out of this kernel to other people to be done in parallel. I think the distribution model was a key part of the strength of Linux, because it allowed a lot of stuff to happen independently of what was going on in the kernel, and allowed the development of the system to happen separately, driving home something that's been learned in the software world so many times, which is that modularity enables parallel development and parallel innovation, and that really helped us out here. So last thing I want to say on this particular segment has to do with Beowulf clusters. How many of you have heard of Beowulf clusters? A reasonably good number, maybe about half. The idea behind a Beowulf cluster is you take a bunch of commodity cheap PCs, you throw Linux on them, you connect them with the fastest network you can find, and what you have is a supercomputer. And this was kind of a revolutionary idea at the time. It too was laughed at pretty hard. I was working at a national supercomputing center at the time these things were coming out, and I could not get them to take this idea seriously there. Supercomputers were craze, right? You couldn't, there was really no interest in that. But of course, these things have won out over time, even though nobody really talks about Beowulf clusters anymore at all, for the simple reason that we have a different term for them now, right? We call them data centers, right? This is really where that architecture came to start, and grew from there. So they can't ignore us anymore, so they start to laugh at us, and they did. We had fun advertisements from Microsoft saying that you can't really count on us. It's all kind of amorphous and vague. We had people who at least styled themselves as respected analysts, saying, "Sure, promote it to your boss as long as you are aware of the risk you're taking and don't mind being fired," all that sort of stuff. But while this was going on, not everybody was laughing. And so we had another really key inflection point in the development of Linux. when Intel announced that it was going to invest in Red Hat. This was a sign to the world that the industry was taking this stuff seriously, that it had a future, that it was going to stick around, it was going to be supported. And then shortly after that, IBM announced that it was going to invest $1 billion in Linux as well. And things were really starting to take off in the commercial world, which brought about an interesting set of things to work out as we started to negotiate the agreement between the kernel community and companies out there. We started seeing developers actually getting jobs, which there wasn't a whole lot of before that. Sometimes they would disappear into these companies and never be seen again. Other times they managed to still participate in the community. And we saw companies participating or adopting Linux and using things. We saw some interesting things. I got to play with what I believe was the first embedded Linux product, which was the Axis camera way back when. We had really wild talk of Linux-powered telephones. This is something that people laughed at the time. This was never going to go anywhere. Of course, many of us now have Linux-powered telephones in our pockets. But where things really sort of started to take off was, again, in the commercial world and companies starting to adopt Linux. And an event that was seen as laughable at the time, which is the initial public offering of VA Linux systems, which had the biggest single-day price increase of any company offering up to that time. And this was seen as laughable because a lot of people thought there was still no revenue model around Linux, no way to make money around Linux. But this really heralded the end of the dot-com era when the dot-com bubble kind of became the Linux bubble. And all of a sudden there was money raining from the heavens on anything that could style itself as a Linux company. A lot of companies were putting out press releases saying, we're a Linux company, give us money too, buy our stock, that sort of stuff. Companies were starting left and right, people were getting jobs. It was really kind of a nice party time for a little while. But the Linux bubble was a bubble, and bubbles pop. So all of a sudden, all that money was gone, a lot of the companies were gone, and we had to start a whole new conversation on how do we make a sustainable ecosystem around Linux that isn't really just based on free money from the heavens and all of that. There was a time of a certain amount of introspection, but I remind you of this plot that I put up at the beginning. Even though the money went away and a lot of the companies went away, the pace of development did not slow. In fact, if anything, it picked up. Driving home really one of the key points of this whole talk, which is that Linux has a life that is very much independent of any company that supports it. Right? It is not owned by any company. It is not dominated by any company. The people who work on the Linux kernel work on the kernel first and their company second much of the time. They'll often change jobs while doing the same sort of work. So it has a life that cannot be harmed if any particular company goes away. This has helped to keep the kernel strong over the years as the industry around it has changed significantly. And I think we'll continue to do so as long as we can sustain this. It's a really important part of Linux that a lot of free software projects don't really have. Another important thing that happened in this era was the very first kernel summit in 2001. This was the first time that many of us had ever met each other. We'd been working together for as much as 10 years, but we didn't know what each other looked like. So we got together, talked about various things, had a lot of good technical conversations. But the key thing that came out of this, in my mind, is that we got to know each other a little bit and learned how to work together better. And really drove this point that in-person meetings are important. We are a global distributed community. We're all over the planet. We don't often see each other. But if we can get together every now and then, talk to each other, really get to know each other, share a beer, we function together much more effectively than if we can't do that. And this is an area that worries me a little bit at the moment, because regardless of how you feel about current US administration policies, it is objectively true that those policies have made a lot of people unwilling to travel to the United States at this time. And that, in turn, means that there will be no significant kernel-oriented development conferences in the United States in the foreseeable future. It's just not going to happen there. It's going to happen somewhere else. And that's not a problem for those of us who are fortunate enough to be able to travel to these events, but not everybody is. And some people really are, at this point, unable to leave the United States out of fear of being unable to return thereafter. So this is going to fragment our community a bit. This is going to impede our ability to get together and to lubricate our functioning in this way. And I think that's going to hurt us. We're going to have to figure out how to deal with that. Hopefully it won't last too long. Meanwhile, on a different front, this is the list of stable releases during this time. So if you look, for a while we were getting out a major stable kernel release about once a year. But if you look down that list, you see that this was starting to slow down. And we were starting to get to where it would take us up to about 3 years to get a release out. This is a problem during a time when Linux is just beginning to take off. And we had so many things to fix and so much to improve. This was really not a good thing. So what was happening? We had a process where Linus Torvalds had to review every single patch and merge it himself. And it got to a point where no one person, not even he, could do this. And so we ran into scalability problems. The whole thing was beginning to bog down. And the fact that we had no source code management system didn't really help much here. So the seeds to the solution to this, or part of the solution at least, had been actually sown some years before, back in 1998. I had a conversation with a guy named Larry McBoy about this thing that he was calling BitKeeper. It was a source code management system that was radically different than anything we had at the time. The current systems were all very centralized. There was the repository, and everything went there. BitKeeper was distributed. People had their own repositories. You could move stuff between them. And then we would set up what he called lieutenants at that time. We now call them maintainers, who would be responsible for a particular subportion of the kernel, accept patches for that, and then send the whole mess up to Linus, who could then trust that result and not have to review all those patches individually, thus allowing the process to happen in parallel and scale things out. This was an idea that was well received in general in the community, but there was a minor problem. The BitKeeper was not free software, and that was less well received. It was quite controversial within the community, but even so, we adopted it in 2002. And immediately some things improved, managed to improve the scalability of our process quite a bit. So by the end of 2003, things had settled out quite a bit. We had the 2.6 kernel out, the commercial side of Linux was growing, and people were not really laughing at us anymore. Which of course leads to that next phase. And yes, they did fight us. You had the CEO of Microsoft saying that Linux is a cancer that attaches itself to everything it touches. We had the CEO of Sun saying there's just no role for Linux on the server. One of those things that really didn't age very well. But we had fights on different fronts as well. The WRT54G was a small home internet router put out by Linksys initially, bought up by Cisco. They used Linux in it, of course, and made a number of interesting improvements to it, made the networking and such work better. But contrary to the requirements of the GPL, did not release the source to this, even when asked. So it took quite a bit of effort from a number of people, some of whom may be present here, to finally get that source code out and incorporate it into Linux. One of the results of that now is that you can't really find an internet router that doesn't have Linux in it. Right, that helped us to dominate all of this. It helped us to make the networking stack in general better, and drove home this point that I want to reiterate, because licensing really does matter. Had Linux been permissively licensed, we would not have had the leverage to extract that source code out of Cisco that we did. And this is a story that has played out a number of times here. It really does make a difference there. But if we're going to talk about the fight in this era, of course, we have to talk about the big one, which was the SCO lawsuit. This guy named Darrell McBride put on his cowboy boots and stood up in front of the world and said that Linux is full of millions of lines of code that were stolen from him and his company in particular, and distributed illegally, and that as a result of that, IBM owed him $5 billion. IBM disagreed. But this cast a real pall over the industry for a while. It was scary for a while. We really did not know how this was going to play out. And of course, it played out very well. It, in fact, played out so well that it made us a whole lot stronger than we were when we found it, for a few reasons. As I like to say, we had the good luck of being attacked by idiots, right? They could have created a certain amount of trouble had they actually owned what they thought they owned, had they actually had a case, and had they not attacked the hardest, most well-financed and best lawyered target they could possibly find. But they did all those things, they lost. But in the process, they drove home a couple of important lessons. Perhaps most important being this one: the free software is not stolen code. During this time, the Linux code base was put under the microscope in a way that I think no other project, free or proprietary, has been before or since. There were billions of dollars at stake here. There's a great incentive to find those millions of lines of stolen code. And there were none. There were none at all. There was nothing there to be found. It was made so clear that people do not work on free software to steal code. They work on it to solve problems and to make the best thing they can. And it made this point far more clearly than we ever could have by ourselves, and nobody has ever really pursued this kind of copyright-based claim against Linux ever since, because it was disproved so convincingly that there was going to be anything to be found there. The other lesson, unfortunately, is that if you have an important project, you need lawyers. If you've created something of value, sooner or later somebody's going to try to take it from you, and sooner or later you're going to run into the regulatory world and all of that stuff. You need lawyers. We didn't really have them then. We do have them now, and we are far better off for it. You can't avoid that whether you want to or not. For a fight on a different front, let's get back to BitKeeper for just a moment. 3 years in, it had become a key part of our development process. Right? Nobody really wanted to do without it because it made everything work so much better than it did before. But it was still not free software, and this led to a lot of friction with its creator, a lot of friction within the community, a lot of unhappiness. And then in April of 2005, the license was suddenly withdrawn, and overnight we found ourselves without the tool that had made our whole process work so well for so long, and everything ground to a halt just like that for about a week. And then Linus went off for a weekend, and he came back with Git. It was a pretty gnarly and rough piece of software at that point, but it got better, and before very long at all, we were working much better than we were even before. We were actually better off after that. And I mean, we were better off, and the software development world as a whole was transformed as a result of that, of course. Leading this lesson that the development tools really matter. I believe that the kernel community has underinvested in tools for pretty much all of its existence. We are, after all, the people who went without a source code management system for the first 10 years. And we see this over and over again. Anytime we do invest in tools, it pays off many times over. I wish that we would do more of it. The other lesson here, of course, is that proprietary software is an unstable foundation. If you were running somebody else's platform, you were subject to their whims. And sooner or later, they're likely to use them against you. This is a mistake we made then. We have not really made that mistake since. I hope that in our coming AI future, we will not make that mistake again. But it is always a threat out there. So then you get to the phase where you win. But we weren't really done yet. We're never really done. We had some problems that we had to solve still. Starting with the development process, which still wasn't really where we needed it to be. The model for a long time in Linux was that we would make these odd-numbered releases that were for development. That was when all the new features went in, you broke things and so on. And then every now and then we would try to pull it all together and put an even-numbered stable release. That's what you're supposed to use in production. This is the model that led to this table that I put up before of ever-increasing times between stable releases. We weren't actually getting those stable releases out. And there were a lot of problems with it, but it kind of came down to this vicious circle where you would get this delay in getting stuff out to users. You had all this code that was ready, it had been developed, but we hadn't made that stable release, so people couldn't use it. That led to a lot of what was called patch pressure, trying to get that code into the current development release. It was perhaps feature frozen, but not frozen anymore because we just shoved a whole bunch more stuff into it because it was ready. And that would break the feature freeze and then delay the stable release further, and you go back around. And it did not work. Stuff kept piling up, and we never managed to get things out to to our users. Now, if you add another line to that table, by the middle of June 2005, it looked like we were still in this mode, right? We were still in the 2.6 stable series. We had not yet started the 2.7 development series that was supposed to bring us the next set of interesting features. But in fact, things had changed quite a bit by then. The 2004 Kernel Summit, held right at the end of the year in this kind of nasty basement in Ottawa, we had a session to decide, is it time to create the 2.7 development release now? And the answer that came out, I think, surprised everybody in the room, that no, we weren't going to do that now. We weren't going to do it ever. That we were going to change the development model entirely. And what we came up with is a model where there would be no more of these even and odd releases. Instead, every release we would do would be a major release, a stable release with new features, and we would do them quickly so that we would get this process moving much more quickly and get stuff out to our users. It took us some years to figure out how to do this well, but we've ended up in a world now where it works like this. We have every development cycle starts with a 2-week merge window where we bring in all the new features. It's usually well over 10,000 changes that come into the kernel over the course of 2 weeks. It's kind of a busy time. And then we spend 7 or 8 weeks stabilizing it. At this point, this works so well that every release takes 9 or 10 weeks. You can set your clock by it. There really have only been 2 exceptions in the last 15 years or so at this point. And if you look at the nature of these exceptions, right, 4.15 was delayed a couple of weeks because we had to incorporate a massive amount of mitigation code for the just disclosed Meltdown and Spectre hardware vulnerabilities that kind of messed things up in the middle of our development cycle. 3.1 was delayed because our main development repository site was broken into. That is the sort of seismic scale of event that it takes to delay a kernel release at this point. Otherwise, we have things working so smoothly that this all just works now. So lessons from this: integrate your changes early. Don't wait for some long-term stable deadline. Get it in there and get it out to users quickly, because otherwise everything piles up and you cannot keep your process going if you don't keep things moving in this way. I have to add the other piece of the development cycle here, which is the stable updates, which come out after the stable release. We don't just forget about it. We add fixes to it as we find them. As you can see, we add a few fixes, like a few tens of thousands of fixes. It takes a long time to find all these bugs and to get them in there. It takes a long time to stabilize things for real. It's just the nature of it. You don't find things for quite a while. But you have to do this in parallel with your feature development. You can't try to serialize them one or the other as we were doing early on, or things are just not going to work very well. One other important thing that happened at that same meeting back in 2004 that I want to emphasize here was a keynote talk by Andrew Morton, who was kind of the number 2 kernel developer at that time. And he put out an appeal to the industry, asking them to stop trying to differentiate their own offerings at the kernel level. Stop putting out kernels with their own special stuff in it, but to put everything into the mainline kernel and concentrate all the development there and do their differentiation at the higher levels. The industry really pretty much took this to heart, with certain notable exceptions. And so, this is what we think of as the upstream first rule now, where we all get it into the mainline, where we can all help to improve it, we can all use it, we can maintain it, we can do all that stuff together and make a better kernel for all of us. Another challenge that we've had to deal with really for the entire existence of Linux, is that some vendors are less enthusiastic than others about having support for their hardware in Linux, or at least free software support in their hardware for Linux. One area of particular pain at this time was graphics drivers. This was complex hardware that was really all driven by proprietary software. So in 2007, when AMD changed course and said that they were going to open source the drivers, it was another watershed moment. It was a vindication of the model that we have quietly had for many years, which is that of patient engagement with companies to try to get them to come around. There are those in our community, including me at times, who have argued for a more litigious sort of approach to companies that don't abide by the GPL, that don't cooperate with our community. But the truth of the matter really seems to be that the way to solve this problem is to continue to put pressure on these companies, to talk to them, to talk to the people in there, to make friends, and to slowly bring them around. And if you spend enough years at doing this, you get a company that not only releases some code, but that participates in the community from then going forward and really becomes a part of the community and helps us. This, I think, is one of the really important parts of how Linux has been successful over all these years, and something that I think not too many people appreciate, but it is an important piece of it. Another important moment, 2011, kernel.org gets broken into. And a lot of people are kind of worried about what could have happened when our main repository server got compromised. Now, it got broken into by script kiddies who had no idea what they had actually gotten hold of, or things might have been worse. But, we fixed it up, we got around that, but it drove home this kind of important point that we hadn't really understood until then, which is that your development infrastructure really needs to be professionally managed, right? It cannot be something that a couple of developers are doing in their spare time, or you're going to have problems like this. Thanks to the Linux Foundation, we have this professionally managed infrastructure now. It works really nicely, and we haven't had this kind of problem ever since. A lot of other projects get their infrastructure somewhere, but you need to find it somewhere. And then the last thing I want to point out here, I want to just look at a very quick case study. In late 2004, the first patches for the real-time preemption project started. Right, this is a project to bring true deterministic real-time response to the Linux kernel. This is something that had never been done for a general purpose operating system kernel, and which a lot of people swore never really could be done. Well, it took a little while to do it. In fact, it took 20 years. But last September in Vienna, the final pull request for this project was delivered by hand on paper to Linus Torvalds, who gladly accepted it. And this project was declared to be complete. It sat there, has been in use. And the point I want to make here is our ability to do this kind of long-term project that I think is pretty rare in projects both in free software or the proprietary world. I don't think there's many companies that can do something that is this long term. And we can do it because we have a project that is independent of any given company, that is really independent of anybody's particular employment at any given company, that we can maintain focus on something like this for that long and use a project like this to make things better for everybody over that kind of a time period. That is part of why the Linux kernel is still here 34 years later, is that we can do this, and why I expect and hope it'll still be here another 30 years from now. And so, oops, that wasn't the button I wanted to hit. Okay. So, and then you win. Linux is everywhere. We got a process that's working great. You're dealing with 4,000 or 5,000 developers per year and tens of thousands of patches and all that. And so everything's perfect this time. And of course, not quite. So I have spent just a couple minutes on a few things where I think we could focus some effort and then maybe have a little bit of time for questions if anybody has that. So one thing I really want to point out is this. I think that the Wild West reputation that the kernel community has is at this point overblown and exaggerated and not entirely accurate. It may have been more so 20 years ago. It is less so now. We are a fully respectful community these days. But the truth of the matter is this, right? This is the Maintainer Summit from last year. I think it is fair to say that while these are all very nice people, we are not the most diverse crowd that you might try to find out there. I mean, we even dress the same. I think that we are missing out on the contributions of much of humanity. A lot of people who have a lot to offer us. This is something that we need to figure out how to address. It's not an easy problem to address, but we need to do that somehow. Maintainer support, Daniel Stenberg yesterday talked about this a little bit. This is a problem that goes far beyond the kernel community. But in the kernel community, companies like to hire maintainers, but they don't really like to pay them to maintain. They pay them for other stuff. And so we have a lot of people still doing this on their spare time. They're overstressed, they're burning out, and this is not good for our community as a whole or for the software. We need to find better ways to support our maintainers. I mentioned development tools once. I'll mention it again because I still think we underinvest in this area. I wish we could do better. We also are going to have to somehow figure out how we're going to incorporate the new sort of round of AI-based tools. There are a lot of very serious questions around the use of those tools and how they will fit into the kernel community. But it is something that we're going to have to address. And then last thing, in 1991, C was a good choice for a language to develop a new kernel in. In 2025, you would not do that. All right. C exposes us to all kinds of security and other types of bugs that you wouldn't have with a safer language. And I believe it's going to increasingly make it hard for us to recruit new developers going forward. We need something else. So this makes me really happy to see the progress that the Rust for Linux people are making in the kernel. It's still nominally an experimental project, but I don't think anybody thinks that experiment will fail at this point. I think that is really going to be the face of Linux development going forward, and I think it's a crucial part of our success in future years. And so I am done. I have 4 minutes and 9 seconds if anybody has any questions they would like to ask. So you'll have to make some noise or something. It's really hard for me to see people in this light here, but somebody must have a question. Okay.
Hi, fantastic talk, John. Not directly related, but with RTL, can we term Linux as a true RTOS?
Okay, the question is, can we use Linux as a true real-time operating system? And the answer is yes, if you have the right hardware. There's a lot of hardware out there that will impose its own latencies that the software can do nothing about. So you need the right hardware, you need the right workload, you need a lot of things to be right, but with the right sort of hardware and the right sort of focus, yes, you can use Linux for true real-time sorts of problems. Okay, behind the board there. Speak loud.
Yeah, so this is regarding the maintenance again. With the recent problem at Intel, there is also a concern that a lot of maintainers were employed by Intel, and with the problem, how do you see this? Will layoffs at Intel affect or will try to increase this problem of having maintainers to get paid to develop these subsystems?
All right, so yeah, the question is how will the layoffs at Intel in particular, which has laid off some maintainers, affect the ability of maintainers to be paid for their work? I think that some of the press attention to the layoffs at Intel has been a little bit overblown. I mean, it's bad what has happened there and what has happened at other companies as well. But I will repeat what I said before, that the work on Linux is really independent of any particular sponsoring company, even Intel, which for some years has been the biggest contributor of patches to the kernel in recent years. Even there, I think that the people who have, the loss of the people there is not going to affect us that badly. Those people will find jobs elsewhere. Some of them I know already have. And you know, it's not good for the people involved. We never like to see something like that, but it does not worry me with regard to Linux as a whole. It doesn't help, of course, with getting maintainers paid, but it doesn't. I don't think it really changes that situation much in any way. Yes?
You said nothing about the Linux Weekly News. How is it going?
How is LWN going? That could be a whole talk in its own right. The short answer is that we're doing okay. We're still here. You know, I mean, we hired 2 more people a little while back. We're seeing some impacts from the current global political and financial situation, but nothing that we can't handle. So we expect to be around for the long term, especially if you all subscribe. All right, probably time for one more if we've got one. Yes?
Microsoft, for instance, has a long history of painting itself into corners with backward compatibility where they get to regret the technical decision. Linux does a lot less of that, but are there any big examples you can think of?
The question is whether we're going to paint ourselves in a corner with backward compatibility problems. And you say that Linux does less of that, but the kernel has a very strong policy of not breaking user space. And so when we do paint ourselves in a corner, we have to live with it. And there are definitely decisions that we have regretted over the years and things that we have to support that we would rather not. We do eventually try to phase things out when we think there are no users of it, or where we can nudge users to things like that. But the only thing you can really do is to try to be very careful about the things that you accept, especially when it is visible to user space and might be something that you were then stuck with going forward. And be reticent to accept those things. You know, there's a patch series out there now trying to affect the way memory management is done by allowing somebody to load a BPF program. And in theory, BPF programs are not subject to API guarantees, but nobody believes that if people come to depend on this and then we break it, that we would be able to get away with it, right? We would have to revert that fix. So, you know, it creates resistance to certain kinds of changes. It makes it hard to get things in because people know that we're stuck with it for decades. But that's just life. Is you know, the role that we have accepted. Having Linux as a separate kernel means that we have to provide a real guarantee to the rest of the world that we will stick with the decisions we have made, and we do our best to do that. And I am out of time. I thank you all very much. Enjoy the rest of your conference.